Hello and welcome to Eiffel Science. I'm Chris.
And I'm Eleanor, and today we're going to be discussing exactly what megaliths are.
Hidden in Lebanon's Bekaa Valley lies a mystery that shouldn't exist. A city built on stones too massive for modern cranes, too precise for ancient tools. For centuries, no one could explain how they were made until now. AI scientists claim they've solved it. But their discovery isn't just rewriting history, it's revealing something far worse. These aren't just ruins. They're a warning we've been ignoring for thousands of years. What the data revealed will challenge everything you thought you knew about human civilization. Join us as we uncover the truth behind Baalbek and why it matters now more than ever. The place that shouldn't exist. Driving through Lebanon's Bekaa Valley, travelers pass vineyards, farms, families selling fruit by the roadside. It's beautiful, ordinary, the kind of place where life moves slowly, where the land still dictates the rhythm of the day. And then Baalbek appears. Massive columns thrust toward the sky, Roman temples that should feel ancient but somehow don't, because underneath them is something older, something that makes Rome look like yesterday. Most visitors walk straight to the Temple of Jupiter. 6 remaining columns, each over 20 meters tall, standing like sentinels against the Lebanese sun. But beneath the Roman grandeur lies what really matters, the foundation. 3 stone blocks sit side by side. Each one weighs 800 tons. 800 tons. That's heavier than a fully loaded jumbo jet. Actually, it's heavier than 3 jumbo jets. And these blocks aren't rough-cut boulders stacked carelessly. They're precision-cut, fitted so tightly together that a piece of paper won't slide between them. No mortar, no gaps, just stone on stone, locked in an embrace that's lasted thousands of years. Archaeologists call them the trilithon. Each block stretches 19 meters long, stands 4 meters high, and runs 3.5 meters deep. They form the base of a platform that the Romans built their temple on top of. Except here's the problem. The Romans probably didn't put them there. The largest cranes in the world today, the ones that lift sections of bridges and oil rigs, max out around 20,000 tons under perfect conditions. That's with hydraulics, computers, steel cables, and teams of engineers calculating every angle. Moving an 800-ton block horizontally across uneven ground, then lifting it onto a platform with millimeter precision, that pushes the limits of what modern technology can do. And someone did it thousands of years ago, without engines, without computers, possibly without even the wheel as engineers understand it. The Roman Empire built incredible things: aqueducts that still carry water, roads that still bear traffic, amphitheaters that still host performances. But their largest confirmed stone blocks weigh around 50 tons. The trilithon stones are 16 times heavier. Nothing in Roman engineering records even hints at the capability to move something this massive. Half a kilometer away, carved into a hillside, sits the quarry where these giants were born. And here's where the mystery deepens. 3 unfinished megaliths lie abandoned at various stages of extraction. The largest, known locally as the Stone of the Pregnant Woman, weighs an estimated 1,000 tons. Next to it, discovered only in 2014, rests an even bigger monster, 1,650 tons, still partially embedded in bedrock. Tool marks score their surfaces, frozen mid-creation like a sentence cut off mid-word. Why did the work stop? The stones show no cracks, no flaws that would make them unusable. The quarry wasn't destroyed by earthquake or flood. Workers simply set down their tools one day and never came back. The blocks remain where ancient hands left them, waiting for a lifting operation that's now millennia overdue. If the builders successfully moved 3 800-ton stones into place, why couldn't they finish these? What happened? What stopped them? Here's the thing that keeps engineers awake at night. Even today's strongest cranes can't move these blocks. So how did ancient builders do it? For 2,000 years, Baalbek has refused to give up its secrets. Empires studied it, engineers measured it, legends grew around it, but no one could make the stones talk, not until artificial intelligence learned to ask the right questions. That's when everything changed. Historical debate. For centuries, the official story went like this: Romans built Baalbek. End of discussion. It made sense on paper. The Temple of Jupiter was constructed during the reign of Emperor Augustus, around the 1st century BCE. Rome was at its peak, conquering territories, building monuments, showing the world what imperial power looked like. Baalbek was one of their grandest projects, a statement carved in stone at the edge of their empire. Roman engineers were brilliant. They invented concrete. They built the Pantheon with its massive dome. They created water systems so sophisticated that some still function today. Given enough manpower, enough time, enough determination, surely they could move a few big rocks, right? That's what historians said. That's what textbooks taught. That's what everyone believed, because believing otherwise meant opening a door no one wanted to open. But some people noticed things that didn't add up. French archaeologist Pierre Montet, working at the site in the 1920s, observed something strange. The trilithon blocks didn't look like Roman construction. They showed no Lewis holes, the carved sockets Romans used to grip and lift stones, no pivot points, no scaffolding marks, nothing that matched standard Roman technique. The stones looked like they'd been placed in one smooth, continuous motion, using methods that left zero archaeological fingerprints. Then there were the local legends. Lebanese families living near Baalbek have told the same stories for generations, stories that existed long before Rome ever arrived. They speak of giants who built the original city. They call it one of the oldest places on Earth, constructed by beings whose names have been forgotten, but whose work remains impossible to ignore. The Bible mentions the Bekaa Valley and refers to the Rephaim, a race of giants who once lived in the land of Canaan. Ancient texts describe cities built by hands that weren't quite human. Folklore? Maybe. But folklore doesn't usually persist for thousands of years unless it's preserving something real, even if the details got mythologized along the way. By the mid-20th century, engineers started doing their own calculations, independent of archaeological consensus, and their conclusions were uncomfortable. The physics didn't work. Moving an 800-ton stone with ancient technology, wooden rollers, hemp ropes, thousands of workers pulling in coordination, required forces that exceeded what any documented ancient system could generate. Friction coefficients, tensile strength limits, load distribution mechanics. The math failed every test. One engineer calculated it would take over 40,000 people pulling in perfect synchronization just to move one stone. And that's assuming ideal conditions that never actually exist in reality. Then came the tool marks. In the 1990s, researchers began examining the quarry surfaces in detail. Some marks matched bronze and iron chisels, tools the Romans definitely used. But others didn't match anything. Some cuts showed irregularity, a machine-like precision that hand tools simply can't achieve. The surface finish on certain sections looked polished, abraded smooth by something more advanced than a chisel and hammer. Geologists added another wrinkle. The weathering patterns on the trilithon stones didn't match the weathering on the Roman columns above them. Some researchers had stated that the megaliths showed erosion consistent with thousands of years more exposure, possibly 5,000 to 12,000 years more. Dating stone weathering isn't exact science, but the difference was significant enough to raise eyebrows. And then there was the alignment. Baalbek sits at exactly 34 degrees north latitude. The platform's orientation aligns with the rising sun at the spring equinox. The same type of astronomical precision shows up at Giza, at Angkor Wat, at sites scattered across the globe, built by cultures that supposedly never met, never communicated, never shared knowledge. Coincidence? Maybe. But the pattern kept appearing. By the early 2000s, the debate had split into camps. Traditionalists defended the Roman timeline. Revisionists argued for something older, though their theories ranged from credible to wild speculation involving lost civilizations and, unfortunately, aliens, which did more harm than good to serious inquiry. What everyone lacked was hard data. Personal observation only goes so far. Tape measures and theories can't force stones to reveal their secrets. For centuries, debate raged in books and journals, but no one had ever put the stones through the one test that could end the mystery: data. The discovery that changed everything. In 2019, something unprecedented happened at Baalbek. The Lebanese Directorate General of Antiquities partnered with the German Archaeological Institute to launch the most comprehensive technological survey the site had ever seen. This wasn't another expedition with measuring tapes and notebooks. This was different. They brought LiDAR scanners, ground-penetrating radar, high-resolution 3D imaging, and something no previous generation of archaeologists had access to: machine learning algorithms trained to see patterns humans can't. The goal wasn't to prove any particular theory. It was simpler than that. Document everything. Capture every surface, every angle, every microscopic detail. Let the data speak for itself. LiDAR, light detection and ranging, works by firing millions of laser pulses at a surface and measuring how long they take to bounce back. The result is a three-dimensional point cloud so detailed it can capture variations smaller than a millimeter. Every tool mark, every scratch, every imperfection gets recorded with surgical precision. They scanned the trilithon, they scanned the quarry, they scanned the unfinished megaliths still lying in the hillside. Terabytes of data poured in, more information about Baalbek stones than had been collected in the previous 2,000 years combined. Then they fed it to the AI. The algorithms had been trained on hundreds of ancient construction sites: Roman quarries in Italy and North Africa, Egyptian limestone excavations, Greek marble works, even prehistoric megalithic structures across Europe. The AI learned to recognize tool signatures, the unique marks different technologies leave behind. Bronze chisels create one pattern, iron tools create another, modern diamond saws leave yet another signature entirely. When the AI analyzed Baalbek's quarry, it found something unexpected: multiple tool signatures. Not just Roman-era tools, but marks that didn't match anything in the training database. Some areas showed cutting patterns with a mechanical regularity that's nearly impossible to achieve by hand. Other sections displayed surface characteristics suggesting heat, microscopic changes in the limestone's crystalline structure that occur when stone is cut or polished with enough friction to alter it at the molecular level. Hand tools don't generate that kind of heat, not consistently, not across meters of surface area. Then the AI examined the trilithon blocks themselves, focusing on the contact points where one 800-ton stone meets another. The deviation from perfect flatness measured less than 0.5 millimeters across surfaces spanning several square meters, half a millimeter, over multiple square meters, on stones weighing 800 tons each. Modern construction achieves that tolerance with laser levels and computer-guided cutting equipment. Ancient Rome had neither, yet someone did it. The research team decided to test something ambitious. They built physics simulations to model how the stones could have been transported from quarry to platform. They programmed in every known ancient technology: wooden rollers, rope systems, ramps, lever mechanics, pulleys, counterweights. They gave the simulation generous assumptions, probably more generous than reality would allow. Then they let the AI try to find any combination of methods that could successfully move an 800-ton block. It ran thousands of simulations, different configurations, different manpower levels, different techniques. It tried teams of 10,000 workers, then 20,000, then 50,000. It tested shallow ramps and steep ramps. It modeled elaborate pulley systems that would make Archimedes proud. It even tested hypothetical technologies slightly more advanced than anything documented from the Roman era. Every single simulation failed. Ropes snapped, rollers crushed, ramps collapsed under their own weight. The physics were merciless. Either the forces required exceeded what ancient materials could handle, or the manpower needed surpassed the entire population of the region. Under every realistic constraint, moving the stones wasn't just difficult, it was impossible. One researcher, speaking anonymously to a German engineering journal, described the moment they realized what the data was telling them. "We built this model to show how it was done. Instead, we proved it couldn't be done." That's not a conclusion. That's a problem. The AI analysis went deeper. It examined the unfinished 1,650-ton megalith discovered in 2014, the largest of the abandoned stones. The algorithm calculated that finishing the extraction would require removing approximately 6,000 cubic meters of bedrock. The stone wasn't just big, it was absurdly, incomprehensibly massive. No structure at Baalbek, no structure anywhere in the ancient world needed or could even use a block that size. So why were they cutting it? Why push the limits that far? Unless the builders were testing something, unless they were reaching toward a capability that went beyond construction and into something else entirely. The I had no answer for that. It just flagged the stone as an anomaly, technically achievable but functionally pointless. That's when the data began to look wrong, or worse, impossible. The team sat with these findings for weeks, running the simulations again, checking for errors, hoping they'd made a mistake somewhere. The numbers didn't change, the physics didn't bend, the mystery didn't resolve. AI doesn't lie. But sometimes, what it tells us isn't what we want to hear. The research team made a decision that would change everything. If Baalbek was an isolated anomaly, fine, it could remain a fascinating mystery, a one-off enigma that defied explanation. But what if it wasn't alone? What if other sites showed the same signatures, the same impossible precision, the same inexplicable construction methods? AI interpretation. The AI was fed information from over 40 ancient megalithic sites scattered across the globe. The Great Pyramid and Sphinx at Giza, Pumapunku in Bolivia, Göbekli Tepe in Turkey, Sacsayhuaman in Peru, Stonehenge in England, the Karnak stones in France, the submerged structures off Yonaguni in Japan, sites separated by oceans, built by cultures that supposedly never met, never traded, never shared a single word. The algorithm wasn't looking for identical construction techniques that would be absurd. Instead, it searched for deeper patterns, correlations in geometry, material selection, astronomical alignments, construction principles, the kind of patterns human researchers might miss because they're looking at individual trees instead of the entire forest. What came back was statistically significant and deeply strange. First, the AI found that megalithic sites clustered around specific latitudes far more often than random chance would predict, particularly 30 degrees north, 34 degrees north, and along the equator. These aren't arbitrary numbers. They're positions where solar and celestial observations yield mathematically significant angles. Baalbek sits at 34 degrees north. So does the entrance to the Grand Gallery inside the Great Pyramid. So does the Temple Mount in Jerusalem. Coincidence? The AI calculated the probability, less than 2%. Second, many of these sites incorporated stones weighing between 50 and 200 tons, when smaller blocks would have worked just fine structurally. The choice to use megaliths wasn't about engineering necessity, it was deliberate, as if the massive scale itself carried meaning, serving a purpose beyond simply holding up walls. Third, certain angles appeared again and again across unrelated cultures. 23.5 degrees, Earth's axial tilt. 51.84 degrees, the slope of the Great Pyramid. 19.5 degrees, connected to tetrahedra's geometry that some researchers link to energy dynamics. These angles serve structural functions, yes, but their consistent recurrence suggested something more. A shared geometric language, a blueprint encoded in stone rather than written in books or passed down through stories. Then came the truly unsettling part, the AI's age estimation algorithms, which analyze erosion patterns, lichen growth, chemical weathering, and other deterioration markers, started returning dates that contradicted conventional archaeological timelines, not by decades or even centuries, by millennia. Göbekli Tepe, already officially dated to 9,600 BCE and recognized as the oldest known temple complex, came back with probability clusters, suggesting portions might be even older. The Sphinx, long debated for water erosion patterns that would require a climate far wetter than what existed during Egypt's Old Kingdom, returned estimates around 10,500 BCE. The Yonaguni structures, dismissed by many as natural rock formations, showed tooling marks the AI classified as artificial, and their depth underwater implied they were built when sea levels were 40 meters lower, which last occurred at the end of the Ice Age. And Baalbek? The AI's median estimate for the trilithon's construction placed it around 9,400 years ago, thousands of years before Sumer, before writing, before agriculture in the Fertile Crescent, before any known civilization capable of moving 800-ton stones with millimeter precision. The pattern was clear. These sites might share more than just construction techniques. They might share an origin, a technological and cultural framework that predates recorded history. a civilization lost to time, buried under millennia of sediment, climate change, and collective amnesia. But the AI found something else, something darker. When the team cross-referenced construction dates with paleoclimate data, geological events, and archaeological evidence of societal collapse, a disturbing correlation emerged. Megalithic construction surges didn't happen during stable, prosperous times. They happened right before the catastrophe. Göbekli Tepe was built around 9,600 BCE, just before the Younger Dryas period ended, with rapid, violent climate change that transformed entire ecosystems within decades. The major construction phase at Giza, if the alternative dating holds any truth, occurred just before massive sea level rises drowned coastal civilizations worldwide. Pumapunku thrived right before prolonged drought devastated Andean highland cultures around 1000 CE. Even Rome's expansion at Baalbek happened during the Roman warm period, a climate optimum that preceded colder, harsher centuries, contributing to the empire's fragmentation. Every time humanity built monuments on a massive scale, collapse followed. Not during the building, after. As if the megaliths were final statements, last testaments carved by civilizations that sensed their own ending. The AI couldn't prove causation. Correlation isn't causality, but the pattern was undeniable. Build big, fall hard, forget, rise again, diminished. Scientists working on the project started calling it the Baalbek pattern, a cycle of brilliance followed by disappearance. The term spread through research circles quietly, mentioned in emails and late-night conversations, but rarely published. Some dismissed it outright. Coincidence, apophenia. Data mining always finds patterns if you look hard enough. Others couldn't dismiss it. They'd seen the numbers. They'd watched the AI identify the same signature across epochs, across continents, across cultures separated by thousands of years. And then someone asked the question no one wanted to ask. What happens if we run the algorithm on current conditions? That's when everything stopped being academic. Forgotten technology or human limits? If the Baalbek builders had the technology to move 800-ton stones with precision that rivals modern machinery, where did it go? Technologies don't just vanish into thin air. They leave traces. Broken tools get tossed in dumps. Techniques get written down, taught to apprentices, improved over generations. Yet at Baalbek, the quarry went silent mid-project, and no culture in the region ever demonstrated anything close to that capability again. The knowledge didn't gradually fade, it disappeared. Engineers have spent decades trying to reverse engineer plausible ancient methods. Every attempt runs into the same brutal wall: physics. Wooden rollers, the most commonly proposed solution, would need to be massive, at least a meter in diameter, to distribute the weight without splintering. Lebanon's ancient cedar forests could theoretically provide such logs, but moving an 800-ton stone would require 30 to 40 rollers arranged in sequence. The friction alone means each meter of movement needs a pulling force equivalent to about 15% of the total weight. That's 120 tons of continuous force. To generate that force with rope, thousands of workers would need to pull in perfect synchronization. But rope itself becomes the problem. Hemp and flax, the strongest natural fibers available to ancient cultures, have tensile strengths around 1,000 kilograms per square centimeter. A rope thick enough to handle even a fraction of the load would be so heavy that much of the pulling force gets wasted just dragging the rope. Ramps create their own nightmare. To achieve a manageable 10-degree incline over a 5-meter vertical rise requires a ramp nearly 30 meters long. A ramp sturdy enough to support 800 tons without collapsing would need thousands of cubic meters of fill material. The builders would move more earth constructing the ramp than the weight of the stone itself, and afterward dismantle it without leaving any archaeological trace. Ancient pulleys and levers, while ingenious, can't escape mechanical advantage limits. Even the most sophisticated Roman polyspastus, a multi-pulley crane system, might multiply force by a factor of 10 to 20. That still leaves hundreds of tons of force needed at the input end. Tread wheel cranes would need to be enormous, and multiple units would need to work in perfect coordination. No evidence of such massive devices exists anywhere at Baalbek. The AI simulations tested all of this. They modeled 50,000 workers using combinations of rollers, ramps, and levers. The virtual stone moved 3 meters over 2 months before a roller failed, triggering a cascade collapse. Resetting took another month. At that pace, moving one stone 500 meters would take over 7 years. 7 years for one stone. The trilithon is 3 stones. The entire platform contains dozens more megaliths. The timeline collapses under its own weight. So what's left? Some researchers propose lost engineering solutions that aren't magic, just more sophisticated than conventional archaeology gives ancient cultures credit for. Counterweight systems using water or sand as dynamic load balancers, acoustic resonance techniques that reduce friction through vibration, admittedly speculative, but persistent in folklore across multiple cultures. Early hydraulic systems using sealed bladders or chambers to generate immense lifting force through fluid pressure. None of these ideas violate physics. They just require knowledge that supposedly didn't exist yet. If a pre-classical civilization did develop such technologies, the knowledge would have been held by specialized craftsmen, transmitted through hands-on apprenticeship, not writing. When those lineages broke through war, disease, climate disaster, the knowledge died with them. No manuals, no blueprints, just abandoned stones and forgotten methods. Another possibility haunts the site. The work stopped because catastrophe interrupted. The unfinished megaliths in the quarry don't show a gradual winding down of ambition. There's no evidence of declining quality or reduced effort. Tools were set down mid-cut, as if the workers walked away intending to return tomorrow, and tomorrow never came. The AI could model the movements. It could map the quarry, but it couldn't explain why they stopped. Climate data offers a clue. Around 10,000 to 9,000 BCE, the Younger Dryas period ended abruptly. Global temperatures spiked several degrees within a decade. Ice sheets collapsed. Sea levels surged over 100 meters. Ecosystems transformed overnight. Any civilization dependent on coastal areas or river systems would have faced existential disruption. Baalbek sits inland and elevated. It might have survived the floods physically, but not the societal collapse that followed. If the builders were part of a larger interconnected civilization shattered by climate catastrophe, their megalithic projects would have been the first thing abandoned. When survival is at stake, monuments become luxuries no one can afford. The quarry workers might have set down their tools not because the work was impossible, but because there was no longer a society to build for. But there's a darker interpretation that the AI's pattern recognition hints at. What if the technology wasn't lost through disaster, but abandoned by choice? What if the builders realized they'd reached a threshold, a point where pushing further came at too high a cost? Resource depletion, environmental degradation, social structures strained to break just to organize such projects. Maybe the unfinished stones don't represent failure. Maybe they represent a decision, the human element. Today, Baalbek exists in a kind of suspended reality. The Roman temples still stand, barely, after 2,000 years of earthquakes, wars, and weather. Conservationists work year-round stabilizing columns, reinforcing structures, preventing further collapse. It's painstaking, underfunded work carried out against a backdrop of regional instability that makes long-term planning nearly impossible. Lebanon itself is fragile. The economy has collapsed multiple times in recent years. Electricity comes and goes. Fuel shortages are routine. Political deadlock is the norm. Yet the people who care for Baalbek keep showing up. They measure. They document. They guide the occasional tourists through ruins that have outlasted every government, every conflict, every crisis the Bekaa Valley has endured. One local guide, whose family has lived near the site for 6 generations, speaks about the stones with a mixture of pride and resignation. His great-grandfather told him stories passed down from his own great-grandfather. Always the same core truth. The stones were here before Rome, before Christ, before anyone could remember. We don't know who built them, he says, standing in the shadow of the trilithon. But we know they'll be here after we're gone. There's a weight to that statement, an acceptance. The stones don't belong to Lebanon, or to Rome, or to any empire. They belong to time itself. Archaeologists working at Baalbek talk about the site differently than they talk about other ancient structures. There's no excitement in their voices, no pride of discovery. Instead, there's something closer to unease. One German researcher, part of the LiDAR survey team, described it as working inside a question we're not sure we want answered. Another was more direct. Every time we learn something new about Baalbek, it makes human history feel smaller, not older, smaller, like we're looking at a photograph of something much larger, but we can only see one corner of it. The scientists who decoded the AI data aren't chasing fame. Most will spend their careers publishing papers read by a few hundred peers at most. Their findings will be debated, challenged, possibly dismissed by colleagues invested in conventional timelines. They know this, yet they continue, because leaving the stones unexamined feels like neglect. Someone needs to bear witness. One researcher, speaking off the record, admitted the discovery brought no satisfaction. Meanwhile, life continues around the ruins with surreal normalcy. Children play near the platform. Families picnic in the shadow of stones that weigh more than commercial aircraft. Perhaps that's the only sane response. Standing in perpetual awe would be exhausting. So the stones become part of the landscape, their impossibility absorbed into daily routine. But the contrast is stark. Modern Lebanon struggles with basic infrastructure, water systems, electricity grids, medical supplies. The gap between ancient capability and contemporary reality feels almost cruel. The civilization that built Baalbek moved 800-ton stones with precision. Their descendants struggle to move humanitarian aid through checkpoints. Baalbek has outlived empires, earthquakes, and wars. It will outlive us too. The stones don't care about theories or timelines. They don't validate or disprove anyone's thesis. They simply wait, as they've waited for millennia, for someone to ask the right questions. And perhaps the right question was never how, or even who. Perhaps it was always why. Why build something so massive it defies explanation? Why push human capability to its absolute limit? Why leave it unfinished, abandoned, silent? Maybe the AI didn't uncover how Baalbek was built, but why we keep forgetting who we are, and why, when we remember, it's always too late. If you enjoyed this video, please like, subscribe, and click on the next video shown on your screen.